All right. I had a bit of a false start there. My husband told me he was leaving to work down in the basement, and then he ran back upstairs, so I had to stop and say, "What are you doing?" But anyway, uh, I can record now. So, welcome to, let's see, we're in the third week of class. I really appreciate your responses and your videos the first week. We're on a bit of a delay here because I'm recording stuff early. Um, but it was really helpful to me. I realized, first of all, just how much you guys have on your plates, which I knew, but hearing the stories, with your families and what you're going through, um, what your class loads are like, it just makes me even appreciate more what you're doing. The second thing is, some of you guys, it's been a long time since you've learned the stuff. So I think what I'm going to do is I'm going to make sure I slow down and make sure we really understand the fundamentals. And if that comes at a cost of not teaching you something at the last part of the class, I'm fine with that. I would rather you leave feeling much more confident at the fundamentals. And so that's what we're going to be doing. So this week is going to be a content heavy class because we're starting our topic, our lesson plans next week. Jessica will be presenting. So this is just content. And it's, maybe difficult to some of us, maybe not, but it's kind of a lot this week. We are not covering regressions. We're in chapter 3 here. Chapter 3 keeps bringing in regression analysis. I just don't think it's worth our time. If I try to teach you regression analysis, you would have a halfway understanding of it, and I'd rather we spend the time on things you really want to learn. None of you wanted to learn econometrics. All right, so one thing that I've decided to do is give you guys my teaching tips. So I know a lot of you guys teach other subjects. All I ever teach is economics, right? That's my only job besides doing research. So I've come up with all these teaching tips over the years, and I can't really do them a lot in this online asynchronous format. So I'm just going to tell you so you can, take them if you'd like to use them. One thing, and I've mentioned this before, is I'll play an economics related song before every class. So my supply and demand song is actually, it's by a Swedish band, The Hives. I actually used to like them back in grad school. They have a song called Supply and Demand. So sometimes I play that. The other thing, and I mentioned this last week, is the pit market experiment by Holt. I have a copy of it. It's an academic paper, but it's basically just describing how you do it. I'll post that on Blackboard so that you guys have that in case you want it. All right, so another thing that I wanted to make sure we cover, and I was teaching my other graduate micro class this morning, and I forgot that I haven't told you this. When we're covering a microeconomic concept, there's 3 ways to understand it. 1 is math, 2 is graphs, 3 is intuition. And you'll notice me jump in between the 3. So I'm going to give you an intuitive understanding of elasticity, then we're going to introduce the math, then we're going to use a graph. They're all, they're all valuable, and I think understanding all 3 really gives us a thorough understanding of the material. So we're doing elasticity this week, and more than one of you said this is something you want more practice with. So I'm pleased that we're spending time on this. Elasticity is a measure of responsiveness, the responsiveness of one variable to changes in another variable. So whenever I hear the word elasticity, I think, okay, what is the responsiveness? There are different elasticities. There's like an advertising elasticity. I don't think we'll cover it, but it's like how responsive is quantity demanded to the amount spent on advertising. Oh, and you'll notice that I have rubber bands here. This is one of my teaching tips for elasticity, which I'll refer to at the end. But I literally like to have these things as I teach elasticity. And if you think about a rubber band that's like really tight, right? Like it doesn't move much, that's inelastic, not responsive. Whereas if you have one that's like really stretchy, that's elastic. So why should we care? Okay, and I know especially your students are, when they learn something this theoretical, it's always on their minds. Why should we care? Elasticity is super helpful. Number 1, we've got the total revenue rule. So I always ask students, how many of you would like to own your own business one day? And whoever raises their hand, I'll say, you have to know this rule. Because if you raise prices, you know quantity demand is going to drop, but you don't know if you should do it. And the total revenue rule is really helpful with this. Number two, understanding the news. Of course, if we think about like marijuana getting legalized, is marijuana inelastic or elastic? Because if it's elastic and you tax marijuana, you're not going to make a lot of money. If it's inelastic and you tax marijuana, you're not going to change anyone's behavior. And then I just referred to this, but tax incidence is one thing that comes from elasticity. The person with the group with the more inelastic curve gets hurt more by taxes. So again, if we're thinking about taxing marijuana, you would say, well, does that hurt consumers? Well, it depends. It depends if they have an inelastic demand. So this is just a general concept. This is not any specific elasticity. But the elasticity between two variables, G and S, is mathematically expressed as the percent change in G over the percent change in S. You could ignore that. That's a calculus thing. So it's basically what are the percent changes. But the one that we're probably the most used to seeing is the own price elasticity of demand. I've never heard this referred to as own before. I just call it price elasticity of demand. But it's basically, we know that there's an inverse relationship between price and quantity demanded. If the price of concert tickets goes up, fewer people will go to concerts. Elasticity tells us by how much, okay? So it measures the responsiveness of a percent change in quantity demanded of good X to a percent change in its price. The sign of this is always going to be negative because of the law of demand. But because of this, it's always negative. Sometimes we get sloppy and we just talk about the absolute value. So forgive me if I do that. If I just say elasticity is 1, well, really it's negative 1. And then the magnitude of the absolute value is whether something's elastic or inelastic. So if it's greater than 1, it's elastic. If it's less than 1, it's inelastic. And if it's equal to 1, it's what we call unitary elastic or unit elastic. But let's think about this. So let's think about like a drug people get addicted to, like heroin, okay? If the price of heroin changes, so the percent change, like let's say it goes up a lot, like a 50% price change, or like, yeah, we'll say 50% price change. How much are people going to respond to that? Okay, well, probably not much because they're addicted. So we're going to see a low quantity demanded change relative to the change in price. It's like if this goes up 50%, maybe this only changes by 10%. That would be an elasticity of 0.2, which is inelastic. Let's use another example of something that's very elastic, which is like foreign airline travel. Let's say the price of like a ticket to Europe goes down by 25%. We would expect the quantity demanded change to, in this case, it would increase by more than 25%. That would be an elastic demand. So let's just remember, we're switching back to intuition here. Inelastic means you're not very responsive. It's not a very responsive change. Elastic, it's super responsive. So one thing that I always do in my personal life and when I'm teaching is I think about examples. So cigarettes is always the example I think of as inelastic. If cigarettes go on sale, it's not like you and I are going to go and say, let's start smoking. This seems like a great deal, right? Smoking is kind of unrelated to the price. So that's inelastic. People don't respond much to price changes. My example of something that's elastic is like very specific. Red Ford minivans. So let's say the price of red Ford minivans increases. No one's going to buy them, right? They'll buy green Ford minivans, red Chevy minivans, red Ford SUVs. So there's tons of substitutes. So people are going to respond in a really dramatic fashion to a price change for something that's specific. So let's think of an example here. So I've got my little notepad that I've actually never used. in a lecture, so bear with me. We've got the percent change in quantity demanded over the percent change in price. So if the price increases by 5% and the quantity demanded decreases by 3%, let's just do a common sense check. Price increases by 5%, quantity demanded decreases by 3%. That's not a very big response. So I would say just right away that good is in, look at this beautiful writing, elastic. All right, so the good is inelastic. But then we can just plug it in. 3%, negative 3% over 5% is negative 0.6. We always refer to the absolute value. That's 0.6. That's less than 1. That's inelastic. So again, I'm thinking about what you guys are going to find useful in your lives, in your teaching. And one thing our book does not do a good job of is actually teach you how to calculate this at this point in the book. And so this is borrowed from an old textbook that I used. I'm going to teach you the formula because I know some of you teach your students this, especially those of you teaching AP Micro. So there's 3 ways to actually calculate it. One is the Arc Price Elasticity. And this is, you take 2 points, P1, Q1, P2, Q2. To find the percent, you're basically finding the percent change in quantity, Q2 minus Q1 over the midpoint, divided by P2 minus P1 over the midpoint. And there's different ways to do it. Most textbooks use the midpoint formula, which is this. The second thing is you can actually, if you have a linear demand curve, you can use the slope to calculate it, and I will go through this with you. The slope is here. Change in quantity over change in price. So you would just take the slope times P and Q at whatever point you care about. Because we're going to see elasticity changes along a demand curve. And the third one that some of you probably don't care about, but I'm going to tell you about it. Sometimes we have nonlinear demand curves, and so you actually use calculus. You take the derivative to get to that. I will never test you on this. I'm just showing you in case you're interested. So let's actually consider an example. I want you guys to calculate the price elasticity of demand. An increase in the price from $2 to $4 decreases the quantity demanded from 100 to 60. All right, so let me go through this. Okay, so what the first thing you do is you say, oops, P1, P2, Q1, Q2. So you just put it in the terms where you can use the formula. I'm going to call P1 2 and Q1 100. I'm going to call P2 4 and Q2 60. All right, so if I was you, I would pause and mark this out myself, but that's up to you. Price elasticity of demand. All right, we're going to take percent change in quantity over percent change in price. I'm going to take 60 minus 100 over 80, which is the midpoint, 60 plus 100 over 2, divided by 4 minus 2 over the midpoint, which is 3. All right, so that's 1/2 over 2/3. Should be able to do that in my head, but I'm using my phone as my calculator. All right, so 0.5 divided by 2/3. So we've got 0.75. So our price elasticity of demand is 0.75. So this is inelastic. Now let's do a common sense check. That says that the quantity response is not very great versus the price response. Yeah, that's true. We had a doubling of price and we didn't have a halving of quantity demanded. So then I'm asking you guys to calculate total revenue. We're going to end this video here. I'm running out of time. But I want you to calculate the total revenue here before and after the price change. And then we're going to basically get to the total revenue rule.